Hello friends, this is your operating system, class 5th. In our previous class, we have learned scheduling algorithm like SRTF, LGF, LTRF. Now here we will learn HRRN, highest response ratio next. So the scheduling criteria for this algorithm is highest response ratio. Here the scheduling criteria is highest response ratio and the tiebreaker is shortest job first. Means that if the two processes having highest ratio is same, then we will see the shortest job first. This is a non-preemptive type algorithm. Okay, to find the response time, we have the formula here: the wait time of that process and the burst time of the process. So here an example. Here is a 5 process at arrival type 2468 and the burst time is 36452. So if we create a Gantt chart of HRRN scheduling algorithm, at time 0 there is only one single process P1, so the P1 will execute. This is a non-preemptive type of algorithm, so it will complete in one go. So there are 3 burst times, so 0 to 3, one process will execute. At a 3 time there is only P2 process have come, so at 3 process P2 will execute up to 6 burst time, so 3 to 9 P2 process will execute. Okay, so now at time 9 all P3, P4, P5 are available for execution, having different burst time. So we will have to find response ratio, because at a P9 there is 3 processes are available for execution. To choose 3 of them, we to use response ratio time. So at P3 here wait time of P3 is 5, because it is in time 9 and P3 come at 4. 9 minus 4, it's 5. 5 is the wait time and the burst time is 4, and also burst time is 4, so the response time is 2.25. Then for P4, it comes at 6, and now the time is 9, so there is a difference in 3, so the wait time is 3 and the burst time is 5, so after applying formula it will get 1.6. The same method following P5. Response ratio is 1.5. Out of these 3 response ratios, 2.25, which is the response ratio of process 3, is highest. So at first P3 will execute. So the burst time of P3 is 4, so from 9 to 13 P3 will execute. After P3 the time will be 13. Now P4 and P5 are available for execution. So again we have to find the highest response ratio. So after applying the formula, here the burst time of P4 is 5 and the wait time, because it is now is a 13 and P4 come at 6, 13 minus 6, it's a 7, so 2.4 and 3.5. Now the highest ratio, now the P5 have the highest ratio, that's why P5 get chance to execute. So after 13 P5 will get a chance for execution, and then P4. So here the final Gantt chart is this, where P1, P2, P3, P5 and P4 will execute in this manner. Okay, now this next algorithm is priority based algorithm. In priority based scheduling algorithm, the highest priority algorithm will execute first, and priority is given in question. The priority condition is given in question. Okay, now the tiebreaker is also given in question. It can be a both type of algorithm. So it's we are non-type or non-primitive or it's primitive. In priority based algorithm, priority must be a statics or variable. In a static variable, the priority is fixed. In variable, priority is not fixed. So in our flavors, there is only fixed priority. So here we see the example. Here the 6 processor having arrival time and the burst time and their priority means the process 10 has given highest priority and the process having a low priority is 4. Yeah, it's minimum 4. So the P1 process get low priority. So after applying Gantt chart, yeah, first we create non-preemptive. If we take all processes as a non-preemptive, then we make a Gantt chart. Here Gantt chart how at so process P1 arrived at 0 time, so at 0 time only one process are available for execution. So P1 will execute. So it is a non-preemptive in nature. P1 will execute full of its burst time. So the burst time is 4, 0 to 4. P1 will execute. At P4, at time 4, there are 4 processes are available for execution. So out of P2, P3, P4, P5, out of P2, P3, P4, P5, we will see the priority order. Now if we see the priority order, P4 is highest order. First P4 will execute. Then after P4, it's 9. Then P5. Then after P5, it's P3 having 6. Highest priority, the P6 will execute. After that, P2 have 5 priority. So P2 will after P5 the time will be 7. Now P6 is also arrive at main memory for execution and its priority is 7. So here and after P4 will have priority. So after P4 having highest priority, so the P4 will be execute. Okay, then after P4 the time will be 5, so the P6 will also available. So now out of other available processor, P5 having highest priority, then other available process, so the P5, then after P5 it's P6 having highest priority, then after P6 P3 having highest priority, then the P2 having highest priority. So it will complete the execution. Now for non-preemptive nature, non-preemptive, first at 0 time only. So now the preemptive nature, if the process is preemptive nature, so at 0 time only process P1 is available because it's a preemptive in nature. At the time 1 there is a P2 process is also available. So at the time 1 here 2 processes are available for execution. Out of 2, P2 will get more priority because it's the highest priority, so the P2 will execute. At time 2 there is only 3 processes are available for. Out of these 3 there is a P3 get highest priority, so P3 will execute. Now the time is 3. At 3 time there is a 4 processes are available. Out of these 4 processes, P4 get highest priority, so P4 will execute. Now the time is 4. At time 4 all P1 to 5 processes are available. Out of these P4 is the highest priority, but its burst time was and its P4 has completed. Now the P4 will get the chance, so the highest priority of P5 is more. That's why P5 is here. Here the P5 will execute for 2 burst time because it's the highest burst time. its burst time is 2 and its priority 9, which is higher than all of them. There's no one, so the process will not preempt. So the computer execution of 2 unit time. Then after that, all processes are available here, but the P4 and P5 have completed and terminated. Now there are 4 processes are available. So after 4, P6 is a P6 having more priority, so the P6 will execute 6 to 12 unit. Now the P6 has completed. Now out of this, process P3 have highest priorities. Now the P3 will execute, then P2, then P1. Here this algorithm's Gantt charts are here. Advantage: better response time for real time of situation. Priority based, the most priority. Here the advantage is that better response time for the real time situation. If we have the process which are more important, then that process will be executed first. The disadvantage is that low priority process may suffer from starvation. If the process is low priority, then it will last off, or if any other process comes in between the process and having highest priority, then that process will execute, and other process having low priority will still wait. That's why it suffer from starvation. Solution of starvation by using dynamic priority. In dynamic programming, what happens if the process is waiting from long time, its priority will increase by 1 periodically. Okay. Now here the round robin, the next scheduling algorithm, round robin. It's a very famous scheduling algo, round robin. Here the scheduling criteria, on which basis scheduling criteria. Its scheduling criteria is arrival time and the quantum. Quantum is a fixed number of time, fixed unit time, and type of algorithm is preemptive nature, preemptive algorithm. Now what is the quantum? Quantum is a max amount of time that can be run CPU. Means it's a time, it's a maximum time, how much time the process can be run on CPU. So here, example, here is a 4 process having equal arrival time and burst time. So there are 4 processes arrival same time, having burst time 3, 6, 4, 5. Now here the quantum is 2, but means that the process only can maximum 2 unit time at a time, at a single go. At a single go, the process can perform or execute only for 2 unit of time. So here the process P1 having burst time 3. Here at 0 time, there are all 3 processes, out of which, so the arrival time is same, equal for this. So we will consider by ID, process ID. Here the P1 get most priority. Then at 0 time, burst time of P1 is 3, but we have to execute only for 2 unit of time. So the P2 will execute from 0 to 2 unit of time and left 1. Then P2 will execute for 2 unit of time, and this is 6. Now 4 units are available. Now the P3 will execute 4 to 6. It's available, 2 unit of time burst time available. Then 6 to 8 P4 will execute. It's 3 unit burst time are available now after execution. Then again in same manner, P1 will execute first, then P2, then P3, then P4. After execution same, if the process are available, if the burst time are available, this next execution P1 will completed and P2 will go. P2 and P4 are available now. Now the P4 available with P2 available with 2 unit of time, so 15 to 17 P2, and the P4 is available with 1 unit of burst time, so P4 will execute. Here the Gantt chart for that question. P2 P1 to P4. Now the number of context switches is 9. Here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 process. There are 10 block of process and 9 number of context switches, because context switching is less than 1 minus less than the number of times process execute. Okay, so find here the shortcut one will here there is a shortcut one for find the round robin process without using Gantt chart. Here the 3 unit of time, there are 3 time bus time. Here is a bus time is 3, so and quantum is 2, so after dividing 3 by 2 we get 2, and same as in 3 means that the P1 process in a Gantt chart at 2 time, P2 will come at 3 time, and P3 will come at 2 time, and P4 will come at 3 time. After adding all these we get answer 10, which 10 times process will comes. 10 minus 1 is a context switching, number of times context switches. Okay, now here are the more examples of round robin algorithm. You can consider it for practice. Now the round robin, here the quantum value, how to decide the quantum value. If the quantum value is very small, means that quantum value is very small, context switching is more. If the quantum value is means that 0 point something, then after 0 point something bus time CPU switch the another process. After switching the other process, then after 0 point something bus time the process will context switch. So context switch time is more than its bus time. So most of the time CPU will be idle. So CPU is idle at most of the time, so it is not efficient. Now another one, if the quantum value is small, then it will be interactive. The CPU will be interactive, means that the P1 process, then after some time means that 1 second, milliseconds, the P2 process will execute, then P3, then P4. A small time, all process will be executed. So the all process get the chance for execution and get response. Now the large, if I have a large quantum value, then it will be a lesser interactive than a small value. But in case of very large quantum value, it may be degraded to FCFS. If the process having large quantum value, then what happens? If the process having 2 or 3 or 4 bus time, but the quantum is 10, what happened? In first, P1 will run, P2 will run, P3 will run, because it have best time less than 10. At a 7, 1 in 1 go, or the full process will run, and P2 full process will run, then P3 full bus times will run. So it will degrade to FCFS. If the P1 process will come first, then it will execute completely, because it has less bus time than the quantum value. Okay, here the advantage that all processes execute one by one, so no starvation. Problem of starvation has solved here. Better interactive, because all processes have equal chance. Here not need to be required a bus time in advance, because here we don't need to require a bus time in advance, because the bus time is not possible in advance. To find out the bus time in advance is not possible. So it is are the advantages of round robin algo. Has a disadvantage also, but it's not as that average waiting time and the turnaround times are more. These are disadvantages and can degrade it to FCFS. Thank you. If you want to download the PDF notes, you can join our Telegram channel. Description in the link. So link in description, so you can download these PDF notes